Assalamualaikum and good day to the panel. My name is Umairah HAFIFAH binti WAHAB, 4-year student from Section 3 Group 1. I will present about my project, which is effect of rooftile loading on mechanical properties of eco-friendly concrete. The supervisor under this project is Professor Madya Dr. Jaria binti Muhammad Joy. The new aggregate from rooftile waste need to be obtained due to the high demand from concrete industry. From this is the best solution to reduce the waste. It can see some of research from researcher in article. Rooftile waste actually is a new discovery from concrete because it's able to promote cement hydration in form of increase the mechanical properties and reduction in shrinkage for the produce the concrete. So focus in this study is to identify the effect of rooftile waste in terms of characterization raw material and concrete analysis.
The most important to form the concrete is the mixture of the raw material. Some analysis need to doing at the aggregates such as SEM, SRD and SRF. Properties of the concrete become concerned when make a changing in the mixture of the concrete. It's beneficial to understand how recycled rooftile waste aggregate characterization and properties will influence the working capacity. There are three objectives involved in this project. The first one is to characterize and analyze the physical properties of recycled rooftile waste for replacing fine aggregate in green concrete. Second is to analyze the mechanical properties of green concrete produced using recycled rooftile waste as a fine aggregate. Lastly, to characterize the microstructure of green concrete produced using rooftile waste.
Literature review will describe about research which has been defined and done by various researchers years ago. It relates to the given title of this project. Some of article prove that ceramic waste can be aggregate. A roof tile belong one of the ceramic product. Ceramic waste as a particle substitute for natural aggregate. It can be considered a suitable alternative to ordinary concrete. It can also state that replacement of natural aggregate to improve the properties of the concrete. Properties of concrete very important to find in this project. It depends on ratio using in mixing the raw material to produce the concrete. Many tests can do to show the properties of the concrete whether it achieved or not. There are some proof that many results in properties of concrete show a good result. Methodology is about the procedure and process involved the experimental work for entire project. The process involved in this project consists of 4 phases, which are Phase 1, preparation of raw material, Phase 2, characterization of raw material, Phase 3, mixing process, and Phase 4, concrete analysis. Figures show the flow chart of concrete, which is the experimental work. Phase 1. Golden Clay Sundarawahad is company that involved in supply roof tile in two categories, which is glazed and unglazed. The first picture from hammering process because it comes with actual size. Hammering process act for break into the small piece. The second picture from crushing process. This process using jaw crusher machine used to grind the small pieces, then followed by milling process as can see in the third picture. Crush roof tile waste to form the standard size of aggregate. Phase 2 consists of 5 analyses. The first is crushing analysis. Crushing analysis consists of sieve analysis. That process used to determine the standard size for coarse and fine aggregate. Second is crystal paste analysis of raw material by SRD. The suitable to obtain the crystal paste material is using SRD, which is X-ray diffraction. SRD is used to determine the crystallographic structure of material. SRD pattern serves as a fingerprint for predict atomic configuration in material. The third is composition analysis of raw material by SRF. SRF, known as X-ray fluorescence. The non-descriptive analytical technique SRF used to determine the elemental makeup of material. SRF analyzes detect the chemistry of a sample. The fourth is surface morphology analysis by SEM. The suitable process to analyze surface morphology is using scanning electron microscope known as SEM. A morphological analysis of deposit, for example, reveals the properties of the liquid phase responsible for the creation of neck, which is particle-to-particle bonding between deposited particles. Lastly is porosity analysis. It's done by measuring the volume gas that physically bound the solid surface at a various pressure. The suitable gas in this analysis is using nitrogen gas. This technique characterizes pore size distribution independent of external area due to particle size of the sample. After do all the analysis, the next step is to mixing process, which is a phase 3. The material for the concrete are cement, water, fine, which is sand or glazed roof tile waste, and a coarse aggregate. Table show the mixing process of the raw material. The next step for mixing process is a slump test. The ratio must be tested in a slump test. Slump test is to determine the workability or fluidity of concrete. It must measure the value of slump fall. Lastly is a phase 4 consists of 3 analyses. The first one is water absorption. This tests to know absorption rate, which is sorptivity of both the outer and inner concrete surface. Water absorption test by hydraulic cement concrete using vacuum saturation. Second is a porosity analysis. In evaluation the deep and porous as well as phase of concrete using vacuum saturation. It's suitable method for determining the permeable porosity of concrete. In order to ensure the precision of the vacuum water absorption method, the pore structure tester used to measure the porosity of concrete at the various curing age. The last analysis is mechanical properties of microstructure analysis. It focuses on mechanical properties, which is compressive strength. The microstructure of the concrete mix will be investigated using SEM, which allow the microstructure of the hydrated cement paste to be visualized. SEM analysis will be done before and after compressive strength to know the difference between after and before.
Expected result for upcoming chapter, which is result and discussion in categorization of raw material, mixing ratio, slump test, and concrete analysis. From categorization of raw material, it can be confirmed whether recycled roof tile waste suitable to replacing fine aggregates. It also can know the effect of physical and mechanical properties when using recycled roof tile waste as aggregate in concrete. For microstructure analysis, the effect of formation of recycled roof tile waste in a concrete can be compared with the common concrete.